Welcome back to Grim 3D. Today we are going to take one more step towards taming the monster. Stay tuned. So I ran some more test prints to try to figure out where my problems are with this monster printer. And this is one of them. And I did a benchy, of course, to test it. A couple of temperature towers. Let's take a closer look at these and we'll see between all of these if we come up with anything and if we've got any kind of better situation on our benchy. Check it out. So hopefully this is focusing pretty well. I quickly designed this and printed it. What I was trying to figure out from this particular print is if my striations in the side here, I don't know if you can see that, if my striations in the side here were more pronounced on the x-axis or the y-axis. And so if you can tell, I actually have some pretty solid striations there, where I would assume the print head is not laying the filament down in the same straight line. They're not really stacking on top of each other. And what I really found out with this on the X and the Y, both directions, is that it really doesn't make any difference. It's striated and kind of a gnarly print surface from either direction. So that didn't help me a whole lot, but it's good information to know that it's not just one direction. So it gives me other places to look. The second thing that I did was I printed this temperature tower. So if we look at this tower, 205, and remember, I'm not necessarily looking for the temperature that bridges the best, and these circles give me a little bit of information. But what I'm looking for is actually if there's a temperature difference in this, the striations that you see on the side of the print here, if a temperature makes a difference. So the 205 is not fantastic. You can see that the 210 actually cleaned up a little bit. Okay, then the 215, a little bit rougher again, the 215. And the 220, for some reason, is looking to me like it's just a little bit cleaner, just a touch cleaner. Let me see if I can get that to focus better. That 220 seems actually to be one of the cleanest. And then 225, it goes back to being pretty rough. And then I actually ran out of filament as I was finishing this up, which is fine. One thing I wanted to do was see if it was the color that made a difference at all. So with the same type of filament, the same eSun, I printed another temperature tower with the same exact G code, and I noticed pretty much the same thing. The 205, pretty rough. The 210 smoothed out a little bit. Okay, the 215, rough again, but the 220 by far is probably the best. You can almost see it a little bit better on the side here. So to me that looks pretty rough down here. It looks pretty, a little bit cleaner there, rougher there, cleaner there, and then once again rough, especially up on this edge right here. You can see the roughness, and that one is smoother, a little tiny bit, and that one's a little tiny bit smoother. So then what I did is I wanted to then print another test print at this 220 degree mark. So I went ahead and I printed a benchy. Now before I printed the benchy, I decided, since I'm using a 0.6 millimeter nozzle on this printer, I should probably start by asking it to print objects that are 50% bigger than the original, because I'm using a 50% bigger nozzle than the 0.4 that you would normally use. So then I used this 0.6 nozzle to print this 150% benchy. And I'm actually pretty excited about these edges right here. Are looking pretty clean. They're not awesome, No, but they've cleaned up quite a bit from what my older benches used to be. If you remember, this was the best actually of the old benchies, and look at that roughness right there. Now this benchy is printed at 100%, not 150%, but if you look at that roughness throughout there, that's what my concern is, and especially in here in the cabin, it's actually quite rough. A little bit of stringing. Haven't gotten to fixing that up yet, but you will notice on the 150% benchy that this curve right here, the striations are quite a bit less, and that's mostly with the temperature change. Before I get any deeper into the upgrades on this machine, I want to make sure that at least my stepper motors are being driven correctly. So that's what we're going to look at today. So here I have Beast on his back, and I have this bottom cover removed right here, and I've got my camera set up here, and right now I've only got the one camera, so I'm going to actually be using my multimeter, my digital multimeter to check the reference voltage on all four of my axes. This is my X, this is my Y, this is my Z, and that down there is my extruder driver. I'm not going to be able to show you my multimeter readings specifically, but I'll call them out because I have the one camera. But first things first, we need to take and find a solid ground from the power supply itself, and the power supply ground comes straight to this screw right here. So I will get my alligator clip to hang onto this screw. Yes, the power is on. Yes, I'm being very, very careful to not damage anything or to shock myself. And to take a reading on my reference voltage for my X axis, I literally just need to get my probe right onto that little potentiometer. And the reading that I get for the X axis with my probe on that potentiometer is 0.826. Okay, now I'm going to do the Y potentiometer, which reads 0.790. Now the Z, which reads 0.720. And then lastly, down here, because it's kind of not in line with the rest, for my extruder motor, I have my right on the potentiometer, and my reading is 0.759. Now I got to do some calculations. So let's put the equation up. The main equation for figuring out your VREF voltage is VREF equals the amps that you want your motor to push at times 8 times your Rsense. So those are the sense resistors between your motor and your stepper driver. My Rsense resistors are R100s, which are 0.1 ohm. So my equation ends up being VREF equals A times 8 times 0.1. Now that's to figure out the VREF, but I already know the VREF. So I'm going to flip that around. Now, because of the associative property of math, I know that times 8 times 0.1 can be combined to times 0.8. So my VREF equals my amps times 0.8. So to flip, since I know the VREF, to flip that to amps equals VREF, I'd have to divide both sides by 0.8, which means that if I take my VREF and divide it by 0.8, I know what kind of amperage is being pushed to each one of my motors. And so on the x-axis with a VREF of 0.826 divided by 0.8, I find out that the amps driving that motor equals 1.0325 amps. And with a VREF of 0.790 divided by 0.8, I find that the amps driving the y-axis is 0.9875, and with a VREF for the Z of 0.820 divided by 0.8, I find out that the number of amps driving my Z motors are 1.025. And remember, the Z motors work in parallel, so you would have to divide that in half. But I don't think I'm going to mess with my Z's this time around because they are working just fine. And on my extruder motor, I have a VREF of 0.759 divided by 0.8. Means that my extruder is being driven with an amperage of 0.9475 amps. Now, I know that the x-axis motor is rated at 1.7 amps. So the x-axis is being driven around 1 amp, so it's a little bit low. The y-axis that I've actually had trouble with, if you look at my last video on the layer shift that I got on the benchies, we find out that the y-axis is being driven quite low. It is a 1.5 amp motor, and it's being driven at 0.98 amps. So right there could be an issue with it skipping while I was trying to print the benchies. The Z motors I haven't had trouble with, and I don't really know what their rating is because I cannot see their model number, and I didn't want to take the whole printer apart to get their model number because they seem to be working just fine. So I'm going to leave those as is, and the extruder motor is a 1.02 amp motor. So with the 1.02 amp windings, it is also being driven at 0.947 amps, which means that the extruder motor is being pushed at very close to its rating. Right now it's being pushed at 93% of its total rating, which means that I could actually maybe turn that one down. A lot of people say that it's safest to run your motors at about 90% of their rating, and that one's at 93% of the rating, but I haven't seen it skipping. I haven't had problems with it, so I don't think I'm going to mess with that one. For this particular tweak, I am going to mess with the VREF on the X and the Y so that I can get their amperage a little bit higher. So the X is a 1.7 amp motor and the Y is a 1.5 amp motor. So if I wanted to run them at full current, I couldn't, because I'm pretty sure that the stepper drivers on this Wanhao main board are 1.5 amp max. So I don't think I want to even take that up to the max. Well, I definitely don't want to take it up to the max, but I think I will put it at, probably put both of those at 1.25 amps. So for a 1.25 amp motor, you times that by 0.8 to get your VREF, which makes the VREF equal exactly 1 volt on the VREF, or 1000 millivolts. So leaving the Z alone, and the extruder seems to be good where it's at, even though it's a little bit overdriven. I am going to go ahead and change the VREF voltage for both the X and the Y to 1 volt even. So now here's kind of a trick I learned online, since it's the screw that actually reads the voltage. As I adjust it, I can have my alligator clips on my screwdriver and read the voltage as I turn it. So this is kind of deep in there, so I will see if it actually works. I am going to get my screwdriver in there on the potentiometer, and I am reading the 0.829, and then I am turning the potentiometer. That took me down to 0.7, so that's the wrong direction. So I'll turn it the other direction. I'm back at 8.3, 8.4. Remember, I'm going for 1 volt even. There's 0.9. There's 0.9697, 9899, 1 volt even on the X motor. Now for the Y motor, I'm going to put my screwdriver back on there, and I know which way to turn it this time, so now I'm at 0.79 and very carefully turning the potentiometer up. 0.83, 0.856, 0.9. Remember, I'm going for 1 volt even for 1.25 amp. Right there, 1 volt even. Very nice. Now I'm going to put this printer back together. I'm going to print me another Benchy using the same G-code as I printed before, and we will see what kind of difference it makes to have those motors driven by a little bit of extra amperage. Remember, the X motor is a 1.7 amp motor and the Y motor is a 1.5 amp motor. Both were being driven with less than 1 amp to begin with, and now they're being driven by 1.25 amps. So they're not really at 90% or 100%. I really don't want to burn up my board. I'm pretty sure the board can only handle like 1.5 amps per driver. So I think we're in good shape. I'm going to try it out. If it doesn't make a big difference, maybe I've got to look somewhere else. I don't know. But for now, that's what I'm trying. That's today's step. Taming the monster. I'll see you after the Benchy. So as you can see in my sudden change of clothing, it's obviously the next day. I actually decided to print a little bit more on the Duplicator 9500 to test my adjustments from yesterday. So what I decided to do was first start with a new temperature tower, because anytime you make adjustments, it's a good idea to have some information from the temperature tower. I was actually surprised with the information that I got. It turned out to be pretty significant, I thought. And then, because I wanted to know which was affected more, the X or Y, I designed and reprinted a smaller XY line smoothness design so that I could see kind of what the D9 was doing with the X versus the Y, and which one of those adjustments might have made any difference or not. Could have gotten worse, could have gotten better. Here's what I found. So this is actually my original temperature tower that I showed you in the earlier part of this video, with the roughness on this temperature tower going all the way from, from the bottom of the top, all the way from 205 all the way up to the 220. And on this one, I had decided that probably 220 was my best bet. It bridged okay, and the surface of the part was a little bit smoother than all the other ones. So my original Benchy was printed at 220 without the adjustment on the VREF voltage and the current driving the X and the Y motors. So here's my new temperature tower, and you could probably see if I get the light on that right. On this one, it looked to me that the 205C section was actually considerably smoother than the rest. So this temperature is actually what I decided to do my new Benchy and my new XY smoothness test in, was this 205 temperature. You can see on this one, as it goes up, it just gets pretty much rougher and rougher. I don't know if you can see that on the camera. Anyways, so you can kind of see it a little bit on the back if you hold it right. There is kind of a jump between each one of the sections here. Not sure what causes that yet, but in the back here, we've got some pretty smooth print. There's like a little piece that comes out there and like a line that comes out there, but when we get up into here, we're seeing like super rough. Like my knife just isn't even running over that, where down here it just smooths right over it. So 205 was what I decided to do. And so then I printed this XY test right here. So this is the X-axis and this is the y-axis, and I'm actually super excited about this y-axis. Let's see if you can see that. See how smooth that is? You can actually start to see where the infill is connected to the inside of the perimeter lines. See that? So I'm really liking this. The Y, my stepper driver current adjustment seems to have made a pretty good difference on the Y. And if you turn it this way, you can almost see the same thing. If you get the light just right, you can almost see the same thing on the X. So it seems as though the current adjustment has made actually a pretty significant difference. So if you remember, my last YZ directional test was a lot bigger, but if you look at this right here, this is the Y, and look how rough that is. And it's so rough you can't even see. There is infill inside of this, but you can't really even see where the infill is. And the same with X. This is X right here. X is just as rough. So that compared to the new one I think has made quite an improvement. Increasing the current flow to my stepper motors and printing at 205 has made quite a difference. So here's my new benchy. Now, the benchy is still not fantastic. Okay, I've got some issues to deal with here in the front or the bow of the benchy. There are some kind of weird lines standing out here, but for the most part, it's pretty smooth. Both sides actually turned out pretty good. I'm not sure what those are yet. I haven't got far enough to start troubleshooting those. But the one place that does look considerably better, I think, is in this area right up here. If you remember my benchy, my first benchy that I showed yesterday, if you look up in here, you see that it's actually super rough. Like, it didn't even lay those lines on top of each other. Like, I can't even run my razor blade up and down there. It just doesn't move. It's so rough. But the new one, with the two changes, remember I changed the current flow through the stepper drivers, and I changed to 205 degrees instead of 215. This actually is quite a bit smoother. Not so rough. It looks like it's finally able to index well enough to put the lines on top of each other rather than to set them, you know, off the side a little bit. So anyways, there's a shot of the two benchy bows. This is the old one, this is the new one. Granted, it's not a super duper difference. I mean, I didn't go from crap to amazingly beautiful, perfectly aligned. But, you know, that's part of the process of dialing in your machine. And what I'm trying to do right now is dial in this D9. I'd really like it to print. This is almost acceptable print quality. There's a few things I would print at this quality. So there you have it. The two different benchies. And if you remember all the way back to the beginning of my fight with the monster, that is actually what the benchy was originally. So I've gone from this to this. In a few quick changes, a few quick alterations, a few days, a little bit of printing, some test stuff. Getting better. Definitely getting better. So, some solid improvements, nothing really earth-shattering, but if I was keeping score, I'd say it's probably Monster 1, Grim 3D 1 at this point. I'm going to consider that a pretty significant win. Getting better all the time, dialing it in, making it print the way I need it to print, cleaning it up. I've got a bunch more ideas for this battle with the monster, and stick around for those. I've got a few parts coming in and some changes to be made. So that's it for this episode of Grim 3D. Subscribe if you'd like, make a comment, just keep it civil, smash that like button, ring that bell, and we will see you out there.